Number 3, they're asking us about, they are talking to us about a circular movement that has a frequency of 60 revolutions per minute, and they're asking us for the period. So to make this, well, we know that a minute has 60 seconds. So it means it does 60 revolutions in 60 seconds. So that way we can know, and the common factor here is 60, so we divide all of this over 60, and that gives us that it makes 1 revolution in 1 second. And this is the period. Exercise, they tell us that a fork has a frequency of 300 hertz, and they tell us also the amplitude. Also they tell us the displacement, and they're asking us for the velocity. So in this case we can use a formula which is this one, where we already have pi, we already have f, and we already have a. So now we have to substitute the values, and that way we get the velocity. In the next exercise they tell us about a spring that is compressed to an amplitude of 35 millimeters. So we have to convert this to meters in order to make everything more easy. So they also give us the constant k in this exercise, and they ask us for the work. So to get the work we have to get the force. The force is calculated with this formula, and we already have k and we already have x. X is this. So if we already have x and k, we can calculate the force. So now we can calculate the work, and the distance will be the amplitude. So that's how we calculate the work. On the problem number 9, they ask us, they are telling us about a wire that has this mass and this diameter. So, and they also tell us it has a tension force of 100 newtons. So they ask us to calculate the velocity of a transverse wave that goes across the wire. So for that we have to use this formula, but we don't have m. I mean, we don't have mu, and we don't have well, the force we already have it. It's 100 newtons. So we have to calculate mu. Mu we calculate it with this formula over here. Now that we have mu, we can calculate the velocity. So that is how we can solve the problem number 9. Now on the problem number 9, they ask us, they are telling us about a wire that has this mass and this diameter. So, and they also tell us it has a tension force of 100 newtons. So they ask us to calculate the velocity of a transverse wave that goes across the wire. So for that we have to use this formula, but we don't have m. I mean, we don't have mu, and we don't have well, the force we already have it. It's 100 newtons. So we have to calculate mu. Mu we calculate it with this formula over here. Now that we have mu, we can calculate the velocity. So that is how we can solve the problem number 9. Besides, they ask us to find the time it takes to the sound to travel through a piece of rock. This is the length of the piece of rock, and they give us the density of the Cooper, which is the thing that the rod is made of, and they give us the modulus of elasticity. So we use the formula V equals to this, so that way we get V, and now V is equal to the distance over the time. Time is equal, that means that time is equal to the distance over the velocity. So that way we can find the time. problem. They ask us for the intensity, because they say to us a measure in decibels of a sound. So from that we gotta get the intensity. So we have this formula. After this we use the logarithmic tools to get rid of this logarithm, and we have to find this number, and this number, it's equal to this. Initial I, we already have it because it is a constant, so from that we gotta clear for the I. Exercise number 5, they ask us to get the frequency of the sound which an ambulance is making. So for that they already give us the velocity of the air, velocity of sound on the air, through the air, and they already give us the initial frequency, and they also give us the final velocity. So all this data we can use it on this formula to calculate the frequency they are asking us to calculate. Exercise number 4, they ask you to get two frequencies. The frequency 1, that is when the object is getting closer, and the frequency 2, that is when the object is getting away. So they already give us initial frequency, and we have the velocity of the air. So what we have to do next is that we use this formula over here. We replace the values of initial frequency, velocity of the air, and final velocity. So at the end they already give us the final velocity. So we get, with this formula we get the two frequencies. We use here plus when it's getting away, and we use minus when it's getting closer.